So, number 33 says a function f is increasing if f of x of 2 is greater than f of x sub 1 whenever x2 is greater than x1. So what this means is the following, before we go any further. The function, when evaluated at the second point, x2, is a greater value than the function at the first point. So what I think about is this. At this location, remember, f of x is like the y variable, which is our dependent variable, which is the height of the function. So here, at f of x1, we think of this as something like this. If this were at f of 2, it was 3, and then f of 3 is something like 7. So as x increases, the y value also increases. Is that clear so far? Again, as x increases from 2 to 3, the y value increases from 3 to 7. It doesn't matter at what rate. It could go up 30, it could go up 2, it could go up 0.1. It could go up like an infinitesimally small number, like 0.001. If this happens, the function is said to be increasing. Okay? Now, the way I think about that is, remember, positive slope means the graph is going up. That's what's happening here. The graph is going up in some fashion. Now, the graph could look like this. Say these are the 2 points, okay? This is 2 comma 3, and this is 3 comma 7, not drawn to scale, obviously. The graph could start at one point and go up to the other point with some exponential growth, or some linear growth, or it could actually have like a square root kind of curve like that. It could have any type of curve. But it doesn't matter. All we're talking about is whether the function is increasing or decreasing. I am, yes. Actually, am I or no? Did I hit this?
Yeah.
I did, nice. Good check. All right. Now, if the opposite happens, what might we call a function? This is increasing, so it's decreasing. So if this were the reverse, if this 3 and 7 were switched, and this point were up here, and this point were down here, then it would be going down in some fashion, decreasing in some fashion, okay? So this says, show that f of x equals mx plus b, show that if f of x equals mx plus b, then f is increasing if m is greater than 0, and f is decreasing if m is less than 0. What does m represent?
The slope, so it's saying that if the slope is positive, it will go up.
Exactly. If the slope is positive, again, it says this. For the increasing example, the first one we did, we're saying the slope is greater than 0 or positive. Nick, isn't that true?
Yeah.
It's completely true here. Goes up, goes up, goes up. Even though you see the curvature starts to come down, it still is increasing. Until, if you remember parabolas, the general shape of parabolas, it's increasing and then what, guys? And then it goes down. Well, when it changes from increasing to decreasing, we call this a critical point in calculus. So the stuff that we're learning here that we're going over relating to slope, I'm doing that so that when you go on to that class, you're more than prepared for it. And you'll see right away that knowing this stuff is really useful. You're going to talk about increasing and decreasing functions in pre-calc also. And you're going to use what's called a number line test, but I'll wait until then. Anyhow, that's the idea of this problem. So if the slope is positive, it's going up. If the slope were negative, it's coming down. It's decreasing. Okay? That's all it's saying. So you have to just give a pictorial image or give an example of the function. Y equals 2x plus 1. Y equals negative 2/3 x minus 4. The positive is increasing. The negative is decreasing. Okay? So the slope of the line indicates if the function is increasing or decreasing. That's a huge key point. You might want to write that one down. The slope of the line indicates whether the function is increasing, and in parentheses you can put m greater than 0. So whether the function is increasing, in parentheses m greater than 0, or decreasing, in parentheses m less than 0. Again, this is just notation. Remember, this just means that m is negative. Just get used to the way it's written. You're more than welcome to do this. I've seen a lot of students do that. M negative in a circle means the same thing. M is less than 0. But it's their own notation. Now this, sorry, this was positive, so that would be positive there. Just in general. Alejandro.
How do you know, like, when you have your own variable, for example, the question 4 involves also,
Problems, number 4.
like I answered it, but how do you know where the variable that you use were C and
Or
P,
CN and P. How do you know which one they go to?
yeah, like I don't know, how do you know, like you put C, like C of P or P of C?
You're looking at number 4? Under problems or under written exercises? Problems, okay. Number 4, it costs Ace Electronics Company $1,900 to manufacture 10 VCRs and 2,200 to manufacture 16. At this rate, it would cost to manufacture 25. All right, it does not matter. You can call it anything you like.
How do you know what order, like you put
Oh.
C of P or P of C?
Again, it doesn't really matter for this kind of a problem. I would say I would make the cost a function of the amount of VCRs because they're asking for the cost at the end if you know there are 25 VCRs. Again, what would the cost of manufacturing 25 VCRs be? So if you want to know what the cost is, write the function as C of x. Because you want the cost. You want the dependent variable. You know that there are 25 VCRs in the end. So this is going to be 25, and then you need to know what the cost is. So by writing it this way, you're able to realize the independent variable x should be the number of VCRs, whereas the cost should be the dependent variable, because that's what you're trying to figure out. Remember in your calculator, when you go to second table settings, and you make it under AS and then auto? Let me refresh your memory, in case that's not clear. So, on the calculator, remember, if we go to second, and then table settings. So sometimes we have the independent on ask and the dependent on auto. The idea behind that is that you are asking something of the function, and you want it to automatically calculate it. Well, that's the same thing that's going on in this problem now. We are asking for 25 VCRs automatically calculate the cost. So it always tells you or indicates which order they should be. Okay? So for this problem, I would do this. I would just say 10, comma 1900 as 1 point. Perfect, okay. I just want to order what else is clear. Again, the number of VCRs was 10 and 16. At the cost, or at the rate of 10, it was 1900. For 16, it was 2200. So put it in that order again because it's x, comma 1. Other questions? Yes, Mike? 24 on our exercises. Complete the table given that g is a linear function. All right. What does it mean again to be a linear function? Somebody give me some sort of descriptive. For a linear function, Jules, can you tell me something about linear functions, please? Its points make a line, very good. Now what does a line do, Jules? Goes up or down, very good. So it's increasing or decreasing at a what rate? What kind of rate? Constant rate. Remember, a linear function increases or decreases at a constant rate. If it wasn't a constant rate, it would look like a parabola or an exponential curve. Okay? So what that means is that to figure out these values here and here, we need to think about the fact that our slope is constant. What happens here from x to the next x? How does this go up by? 2. Goes up by 2. And what does this happen here, Manny? Up by 3. So delta y over delta x would be 3 over 2. The slope is 3 halves. So far, so good? All right. This went down by how much? 4. So clearly we got some crazy business going on here, right? It went up, now it's going down. 6. Sorry, thank you. I yesterday in the chat. Goes down by 6. So for this to happen, what do we have to think about happening here? The y value earlier went up by 3, but now it's going down by 6. Can somebody intuitively tell me what's going to happen to the x value? By how much? 4. Very good. Remember, this value went up by 3, and then we see a gap of -6. What is the factor multiplicatively that relates these two? Isn't it negative 2. 3 times negative 2 yields negative 6. So if you multiply this quantity by negative 2, because that's what's changing here, so here you just subtract by 4. And again, what you'll notice is that 6 over 4, ignoring the negatives because they cancel, 6 over 4 is still 3 over 2. So the slope is not changed in the table now. So when you go down by 4 here, this is going to go from 4 to where? What's going to happen here to this value? 0. Very good. Again, it was 4. The arrows are wrong. I apologize, guys. Smart boarding I teach you was like an inch above where it should be. There we go. So this goes from a 4 to a 0. Because again, we lose 4. And look at the ratio again. You see the 6 to 4. So what's going to happen on the next one? We go from 0 to negative 2. So this goes down by 2. And earlier it went up by 2. So instead of going up by 3, now it should go, everybody? Thank you. So negative 2 minus 3 is negative 5. Okay, so we see that the delta over delta is constant. That's what makes up a linear function. Without that, it's kind of, what's the word? Unpredictable, right? If you did not know it was linear, would you be able to choose those values? So the direction said exactly that. The direction said, given that g is a linear function, it needs to be stable. If it's not, you have no idea about the concavity. That's another word. We're looking at the change of curvature. Number 9, Bravos. Nick, was that yours by any chance also?
No.
What was yours, Nick? Look at both.
I was going to ask you dumb questions.
I'm sure it's not. Can you ask it?
If you have a linear equation that increases and decreases in that point, I was thinking like, would that point not, it wouldn't be like increasing and decreasing?
Absolutely 100% correct.
Yeah.
Great. It's called, now in engineering, we call that a stable point. And think about it, right? It's not increasing nor decreasing. Now, actually, sorry, at the top, if we're like this, it's unstable. At the bottom, it's stable. Either way, they're labeled by their stability. Now, in calculus net, what do we call that when it gets to the top? Absolute or relative maximum. Very good. Because you aren't going any higher, right? Aren't you starting to turn around to go lower after that? Because now the function is decreasing. So when there's a change from increasing to decreasing, you have a max. When there's a change from decreasing to increasing, you have a, what's the word? A low. What's the word though, mathematically? This is a max. This is a, what? A minimum. A minimum. Sorry, man. A minimum. Your hand went up and actually said it. You waited a little longer. A minimum. Very good. Okay. Now, there are points that have changes in concavity, but they're not a min nor a max, right? We'll talk more about those in calculus. It's a good point. Now, looking at Ned, you get the idea that we're on the same track. All right, Alejandro, number. You're doing conversion factors, okay.
How do you decide,
Same thing again, which is which?
like what order? Because I did it, like I got the right answer, but after like putting different orders and orders there. Because at first, I put Celsius to Celsius, and then I put,
Whenever there's a conversion of any sort, if you have a table of inches to feet, or meters to feet, or yards to leagues, or anything, you always think about each unit as x and the other one as y, always. So for this case, I would say 0, 32, and I would say 100, 212. Sure you do. No, you will. The thing is this, Alejandro. You need to resolve the equation sometimes based on what they're asking for. In this case, they said what degrees Celsius would you correspond to a 98.6 degree Fahrenheit. So you can make 98.6 degree your x value if you want to, that's fine, to make it easier. But if you do it the other way, you have Fahrenheit as a function of Celsius. All you need to do is resolve the equation. Solve analytically for the equation. It's important that we go over this stuff. I'm glad you asked. So we have 0, 32, and 100, and then 212. The common freezing and boiling points of water. So in this case, it does not matter again. If I do it this way, I think about, well, what is my slope? What do I get as a slope here? Who has the reduced fraction? 9 9/5 times Celsius. Now, is there a y-intercept here? 32. Where are you getting the 32 from? Yeah, take the first coordinate, plug it in, put a 0 here. Come 0 equals, and then you're going to get over here, you're going to get your 32 value. Now,
Mr. Howell, which 9 are we doing? It's like 3.
part A, find the linear function. Part B asks you to
No, I
input
mean,
a value.
like, there's 3 different 9s. It's
Problems. Yep, sorry, you're right, because there's the mixed review as 9 also, right? Now, once you have this function solved, what do you do to figure out if you're given a Celsius instead of a Fahrenheit? I call this X, it should be Celsius. If you're given a Celsius instead of a Fahrenheit or a Fahrenheit instead of Celsius, what would you do? Yeah, transform, good word. What does that mean, transform? To change it, all right? So let's say, in this case, I want to solve for C, man. How would I solve for C? Because a lot of you had trouble on the last test with like different little things like this. So I want to make sure we're clear. Well, you have this plus 32 though first. You gotta get rid of it. Yeah. You gotta write this as n minus 32. Okay? And now you can do that. So now we have 5 ninths. F minus 32 equals Celsius. So depending on which variable you're given, just resolve the equation. But don't let yourself think, because I notice people are erasing a lot of stuff in their test, and I've seen some things that are right that are erased. Use like some sort of thought process in the middle of it that doesn't always lead back to the beginning. A lot of you are getting the wrong answer and starting over. It's not always the best bet. Because what I noticed was a lot of people ran out of time. Did you all agree with that? You ran out of time. And what did we do in this class? Was it an additional 20 minutes? 10? Just 10?
Yeah, just
It was like 17 or something like that.
no.
Okay, 10. Sorry. So the other class had less time in their section. I do, yeah. You're gonna have one. I'm gonna put some notes on the board. There's gonna be a few things I want you to copy, definitions real quick, and I'm gonna give you your test back while I do that. Any other last questions, Jules?
Yeah, how do I get the function x equals x? Like, if you have a look at like my intercept, how would I get that? 'Cause that's part
Which
C.
problem are you talking about?
Number 9, part C.
And what temperature do the two scales give the same reading? So we want to figure out when the two values are identical to one another, right? So why don't we just call the book x and solve for x? Think about that, right? Think for a second. And it's not, Jules, it's not always intuitive right away. But if you want the Fahrenheit temperature to be the same as the Celsius temperature, call them the same thing. That means they are the same by definition, right? So call them both y or x or alpha or any variable. Doesn't matter. And then solve for the variable. Does that make sense?
Yeah.
I would do that. I would say this. I would move this over, subtract it, and then divide or multiply by the reciprocal. That would be a negative, right? We look at negative 4 ninths, and then multiply by negative 9/4 on both sides, times 32. That would be negative 72.
Answer the back of the book, like for the equation now, and see if the thing that I want to solve for is
Okay, which was?
C of x equals 5 times x minus 160 over 9.
That's 160 over 9
9.
for the general function. Maybe the book's giving a different form of
It
it, but
looks the same because I tried to look.
yeah. They must do it a different way because they must use the numbers out of that. They probably get the slope and the difference there. That's where that number comes from.
Yeah, the points that I have is for the
Yeah. Okay. All right. So what I want you guys, we good on questions? All right. What I want you guys to do is to quickly copy down some notes. I'm going to give you back your test while we're doing that. I'm going to talk about them.
Was this for the first quarter?
The test?
Yeah.
Correct. It was. Okay? There's a lot here to copy down, guys. If you know something and you're totally sure of it, obviously it's up to you to decide what you want to copy. But if you don't know something and you get it wrong on the test, and I don't see in your notes, it's probably going to bug me. So, do me a favor, can you do that? I'm going to look at your notes there in the quarter, yeah. I'm just going to collect them. You're not going to get a grade, but I'm just going to browse. I keep my own notes on. So I'll ask you to turn them in, but you won't get a grade. I can never put that on the syllabus. So I wouldn't tell you that. Just spring it on me. I look at them just out of curiosity. And if you don't turn something in, it means you don't have notes. So you don't have to, obviously, but then I get the impression that you don't have notes, and it doesn't bode too well. The grades ranged widely on the test. There was 1 100 in the other class, unfortunately. There were a few 90s in here.
There's a what to 100?
There was one grade of 100, and there were a few 90s in here, but there were also some very low grades. So there's a high, what you would call standard deviation, which is something that is not good. You need to work on this class. Which means things like this, where we have to stop and ask questions on homework, really need to happen if they exist. And it can't just be, no questions. So you guys need to make sure you advocate. You have a question you ask, right? You have fraction help and stuff. Because people struggle. I'm going to go with the problems right away as soon as you're done tapping, so take your time. So the highest grade in here was a 92.5. Alejandra and Jules both got the same. There's another in the 90 there. That was it. Give me an idea where your percentage was. Like terms? Okay, so halfway? Others halfway? Awesome. Keep writing, please. I don't know if your test on your desk. Just don't even turn it over yet. Just keep writing things up, and when you're done, then turn it over. And I was thinking. Please. Just be here. You want me to scroll up a little bit? Should I scroll up a little bit? You're on coefficients still? All right. That sounds terrible. I'm sorry to hear that. Relax. previous class did it, but make sure you keep using pencil on your tests and stuff. The other class, like 3 people use pen for some reason this time. Not sure why.
Is there,
Yes,
what is the, like, percentage?
I'll tell you, the average and stuff. I'll tell you one. They calculate one too?
No, that's not what I'm talking about.
Oh, good.
What is what are test scores and what are problem set scores? Every total.
Hold on, I've got it in the syllabus. Because it's different for science and math, and I don't want to misquote myself. It's 70% test, 20% homework, 10% classwork,
70% test.
20 homework, 10 classwork. Homework consists of homework grades out of 5 plus your problem sets. All those count. So your problem set worth 50 is pretty much worth 10 homeworks. Yeah, problem set next quarter. It's going to help a lot of people, really. And you guys are getting better at it. And you need to keep getting better at it. Next quarter, problem sets are going to count as tests.
Yes.
So we're good.
Okay? Now, they will not count as 100 points, but if they're worth 50, it's pretty much half of the test at that point. Does that make sense? If not, if they're a little bit more worth a little bit more, then it's 3/4. Some might be shorter, worth only 30 points. You can think of that as like a quiz. Nick?
If you want to get academic honors this year, or you got like really bad grades in the first semester, will that affect us in the second semester?
What's the number you need? Does anyone know?
It's for AP for honorable mention, 85%. So that's
No.
It might be.
Never mind, I'm fine.
Really low.
But you need 90s in everything. Not like
Are we almost done? We almost done copying? Yeah? All right, the other average will be, see, all right, don't take this as a insult to your intelligence, please. Unfortunately, it was a bad test this week. The average in here was a 65, and the average in the other class was 82. So we need to step up our game a little bit. We had people that were in the 90s, we had some people that were in the 30s and the 40s. Altogether, though, as a whole, it puts the class average around, actually exactly around. It depends because there's more students in our class than sometimes. Average is 74 for the whole class. So what that means is that we need to do a little bit better if we're having trouble on stuff and we're not asking questions about it or coming extra help maybe. Maybe I gotta go a little bit slower sometimes. But I'm trying to keep up at a pace so that you guys are well prepared for your future classes and for SAT. So try to bear with me. I know it's new, it's the first quarter. Grades could be a little bit low. Did anybody honestly, and just, you know, if you want me to know, I can turn around, somebody can count. But just to show of hands, do people actually forget about the test? Is that a possibility? Some people actually forget? 2, yes, okay. I mean, if others did and you want to talk privately, it's fine. But I know that some people really suffered. And the thing was that the people that did really poorly or might have done lower than they expected is just that. They've done lower than they've done the past 2 tests. So some of you that got a very low grade, that was not your usual. So I understand that there are flukes. So I'm going to look at the quarter grades and see if there's anything I should do or else. Any questions on the generic terms? I want to quickly go through them, and I'm going to ask just really quick if there's any questions on any one individually and what I think there is about each. It's very important that we get this because we're going to talk about polynomials for the next, good chunk of the term. Polynomial functions come up a lot. They're used a lot in calculus. They're used a lot in engineering. There are things called Taylor series functions, which use polynomial functions to estimate other ones. Now, terms you're going to hear are used over and over again. You have to have these down pat. Okay? So first of all, poly means, everybody? Many. Mono means one. Monomial, one term. Okay? So a constant, a variable, or a product of a constant and variable. This is a single term. I skipped constant, sorry. Everybody know what a constant is? What is a constant just? A number. Okay? Now, you can have constants like A, B, and C, and you solve for them and they are a number. Or like in physics, G equals negative 9.81. It's the acceleration due to gravity on Earth. It's a constant. It isn't no less. It is a number, but it's represented by a variable or a letter. Capital G is the universal constant, or gravitational constant, 6.67 times 10 to the negative 11, which is something else random. But these values are constant in the universe. That's why their names are the word constant. They do not change. So again, a monomial has one term. Coefficient, the constant factor in a monomial. So just looking at our examples here, is it clear what these coefficients are? What if there's no monomial there? What's the coefficient? It's 1 here, Peter. You're right. If there's nothing in front. What if there's nothing there at all, Peter? Then what's really there? Zero, exactly. Again, if there's no term there, if the term is missing, the constant or the coefficient can be the same thing. They're really zero, right? It's non-existent. Like terms, and that's important, by the way. Remember the matrix, when you're missing the variable, you put the zero placeholder there. That's why I'm going over that, so we recall when you use it. Like terms, monomials that only differ in their coefficients or they're identical. So everything else is the same about these except their coefficients. Okay, the 3 and the negative 5 is the only thing that differs. You could have a 3 in front of both of them, and they're still like terms, and maybe you could add them together. Or maybe you could subtract them and get 0. Let's see what else. Polynomial, the sum of monomial terms, so several of them. So I say sum, but what is the definition of subtraction here? Definition of subtraction in that? The difference, good. What did I give you terminology beginning here as adding to what? Yeah, adding the negative or adding the opposite. The difference or adding the negative or adding the opposite. So when you hear the sum of two things, you could have a negative sum there and realize that you're just adding with the opposite value. The degree of the variable. The degree. The number of times the variable term occurs as a factor. As a factor. It should be singular. So for example here, the degree of x is 2 because it repeats itself twice. The degree of y is 5 because it repeats itself 5-fold. Okay? The degree of a monomial is the sum of the degrees in that term. So this degree of x is 4, there's the 4. This degree is 3, there's the 3. Summing them, you get 7. Finally, the degree of a polynomial is whichever is the highest term. So, quickly do this. Degree is, everybody, 4. You gotta focus, come on. Degree is 4. What about this? 3 is the sum. It's 2, that's right. 2 plus 1 is 3. 6. 6 is the highest. The degree of the polynomial is 6. Whatever degree of each monomial is the highest becomes the trump card. What does a trump card mean? Somebody says that in life, some another term.
It's like an ace.
It's like an ace in the hole. Very good. It means that you have a trick up your sleeve or like overpowers other stuff. So in a game called Spades, have you played Spades before? There's a game called Spades and a game called Hearts. If you play Spades, you can flip what's called the trump card. You can play a trump card, which overcomes the other cards. It wins the hand. It's a spade. All right, let's look at a quick example here. Simplify a range of terms in order of decreasing of x, and then determine the degree of each. Okay, so the first one we're going to look at here is going to be 3x minus x squared minus 9 plus 4x plus 2 minus 5x. Should take us we're talking 10 seconds to do this kind of problem. So again, all we're doing is simplifying and arranging them in decreasing degree of x, not y, there's only x. making negative x squared. I like the negative there. Start with that. After that, what do we have? Karina.
3x squared is -5x, which is 2x.
Good. Again, 3 and 4, 7. 7 minus 5 is 2. Lastly, but not least, right? Good. So they are in decreasing order of degree in x, and they are simplifying. Part B. X squared y squared minus 8xy to the fourth plus 2x to the fourth y plus 5 x to the third y to the third plus 2x to the fourth, 2xy to the fourth minus x to the third, y to the third. I'm going to scroll down a lot. Does everybody have the top one copy? Anybody need me to leave it up? The answers are right. All right, like terms. Starting now with the highest degree of x. The problem did not ask for the highest degree overall, but the highest degree of x. What do we got there? 2x to the fourth y. Let's put all the x's. Agreed. It's the highest one. Is there anything else with that? No, right? So that's by itself. So we have 2x to the fourth y. Next. Somebody else? Very good. So 5 minus 1 is? Good. So we have plus 4 x cubed y cubed. Well done. Next. Because we're going from decreasing degree of x. We need to look at the, look at the degree of x. Isn't that a 4? And what is this? Okay. But if it were decreasing degree overall, this is a degree of 6, isn't it? And this is only a degree of 5. So that would be the reverse if it was overall. Works. Okay, so you're combining these two, right? So negative 6, very good.
Yeah, x squared, squared.
Anything else? Let's combine anything there? See Erickson on that squared? And you use a linear term? Remember, it's decreasing of x. So we have 4, 3, there's the 2. Okay? So we're going to jump the gun there a little bit. Be careful. We're going to have a negative 8 and a 2 giving us negative 6 x y to the fourth. Yeah, this should be positive, sorry, because we had the negative and the negative 6. Where did this come from? This 5 here minus this 1 right here. Yeah, that's better before. The coefficient is the 1 here. That's the key to remember, negative 1. Let's take a quick look at the next one. Pretty simple also. I should be able to do this just as easily. Do part A right away, please. Part A right away. Part B is no different at all, so there's a difference. So think about the definition of subtraction. Take tonight off. Catch up on your other work, please. This week on Friday, I'm not going to be here. Just give you a heads up. Do you guys have class Friday, or is it your day off?
No, we have class.
You do, right? Is the other class I put them in a box. It says honors algebra 2 text. Go jump into this tomorrow. Have a good day, guys. Those of you that want to talk about anything, please feel free to come by during an off period or after school. If you want to come by right away, I have some time to chat if you'd like to.